Hello, this is the demo of flyweight design pattern using FLTK. My name is Shomik Dotto.
And I am Arif Ali, and we are students of IIT Bombay Computer Science Department.
Here, I will give a brief introduction about flyweight design pattern. Then I will show you the application we have made and what experiment we have done with flyweight design pattern. Let's start with the introduction. So what is flyweight? It is a structural design pattern which aims to optimize existing application by sharing the similar objects. What is the problem statement here is that when we build an application, it has many objects, and especially if those objects share some common states. So while creating those objects, we unnecessarily duplicates all those states and in turn wasting memory. What solution Flyweight is proposing is that it's segregating the list of states of our objects between two parts. One is intrinsic, another is extrinsic. So extrinsic is the context specific states which every object has to have unique for them. Intrinsic state are the shared state which we can keep in a common place like in a form of cache, and all the objects when getting initiated will use from that common place only. Now let's check out the example we have made. So this is an application we have made where by clicking 5 balls being created at a time, we have given options to create beach ball, basketball, or football, soccer ball, that is. So the idea here is we are creating many objects, right? But if we can see, only each objects have its own image. But now if we can see closely, only 3 images are there, right? So what Flyweight, using Flyweight, what I have did, we have created a image cache where we are keeping only 3 images, and while creating these ball objects, we are sharing these images. So when objects are numerous, the only 3 images will be there in memory. Fine. So we have done performance testing also. We have done with a 20k by creating 20k objects. So with non-flyweight application, we have found at least 392, that is 400 MB memory space is being needed. But with flyweight, it's reducing one third, at least one third or one fourth, that is 200 MB. So it's a huge reduction with flyweight. So that's it. Now Arif will give a basic, will show you the application specific class diagram and its code walkthrough.
So this is the class diagram of our application. The client represents the main function, which creates the simulation window and which has these two parts, that is the ball simulator and the choice panel. Choice panel has the 3 radio buttons that we have shown, and the ball simulator is actually the composite class that contains all the balls in a vector. And this is the actual ball class that is represented by each ball on the screen. So it has the position and velocity and an intrinsic state, that is the flyweight. So this flyweight class contains the image and the radius of each balls. So whenever a ball is to be created, the ball simulator class constructs the ball by first consulting the flyweight factory class, that here, which maintains a cache of each ball type and its associated flyweight, and it returns the flyweight. So continuing, this is the ball simulator class that we have shown. So this contains this vector of balls and enum of ball type, which stores the default value of soccer ball as the current ball type. So if you see the handle method, that for each click we are creating 5 balls by making random velocity, radius, and at the center x and y at the where the click is performed, and we call this function add ball. So let's see the add ball. So in the add ball, we first consult the flyweight factory class to get the ball type for this particular current type that is in the state of this object, and then we create the ball by passing in this ball flyweight. Let's see the ball context class. So this is the each ball that is seen on the screen. So the position and velocity is here. This is the constructor, and this is just the updation logic. So in the drawing, we just draw the image as the intrinsic state, which is constant for each ball type. So this is the ball flyweight factory class, which contains a static method called get ball type, and inside it we have a static hash map that is pre-filled with these 3 values for each flyweight type for each ball type, and whenever a particular type is to be requested to be made, and we just return the corresponding flyweight. And finally, this is the flyweight class that is common for each ball type. So we just store the radius and the FLPNG image, that is the image that is shown, and this is the global ball type enum for beach ball, basketball, and soccer ball. So that is the relevant section for the flyweight design pattern in this application. Thank you.